ions. There is attraction between positive and negative ions, and the attractive force between the positive and the negative ions, that is called the ionic bond or electrovalent bond. The attractive force, force of attraction between a positive ion and negative ion.
Sir,
Yes.
Sir, Gauri is there in waiting room.
Okay. So, the attractive force between the positive ion and the negative ion, that is called the ionic bond or electrovalent bond. I repeat, when electron transfer is there from one atom to the other, there is formation of a positive ion or cation and a negative ion or an anion. Naturally, there is attraction between the positive ion and the negative ion. And this electrostatic force of attraction between the positive ion or cation and the negative ion or anion, that is called ionic bond or the electrovalent bond. Attractive force between the ions, that is a ionic bond. And the compounds which are composed of positive and negative ions are called ionic compounds, or they are called the electrovalent compounds. The compounds consisting of positive and negative ions are called ionic compounds or electrovalent compounds. And which type of atoms can form the ionic bond? For that, we have to think of the ionization enthalpy and the electron gain enthalpy. Usually, the ionic bond is formed when there is reaction between atoms with a very low ionization enthalpy. Atoms with a low ionization enthalpy plus atoms with a high negative electron gain enthalpy. High negative electron gain enthalpy. And such atoms can form ionic bond or electrovalent bond. There is reaction between atoms of or elements of very low ionization enthalpy and very high negative electron gain enthalpy. Say, for example, you take say group 1, that is alkali metals. That is the elements of group 1. They have very low ionization enthalpy. That is because they are the largest atoms. They are the largest atoms in each period. Similarly, you go to the electron gain enthalpy values. Say group 17, that is halogens. That is a group 17 elements. Fluorine, chlorine, bromine, iodine, etc. Group 17 elements. These are having high negative electron gain enthalpy. And so, if there is reaction between alkali metals and halogens, the bond formed will be ionic bond or electrovalent bond. You see, the ionic bond is formed when there is reaction between atoms or elements with a very low ionization enthalpy. Say, for example, alkali metals of group 1 and elements or atoms with a high electron gain enthalpy. Say, for example, halogens or group 17 elements. There is formation of a ionic bond or an electrovalent bond. Let us take one example for this. That is the reaction between sodium and chlorine giving sodium chloride. Let us take this reaction. Reaction between sodium and chlorine. You know, atomic number of sodium, that is equal to, do you remember? Atomic number of sodium is equal to?
11.
Yeah, it is 11. And therefore, the electronic configuration of sodium will be 1s2, 2s2, 2p6, 3s1. So, in the outermost shell, in the valence shell of sodium, there is only one electron. Now you think of chlorine. Atomic number of chlorine, do you remember? It is 17. And the electronic configuration is 1s2, 2s2, 2p6, 2s2, 2p6, 3s2, 3p5. See? So, in the valence shell, in the outermost shell of sodium, there is only one electron. That is in the 3s level. So it is a 3s1. That is the valence shell or outermost shell configuration of sodium. Now, the outermost shell or the valence shell of chlorine, the configuration is 3s2, 3p5. That means totally there are total number of electrons that is equal to 2 plus 5 is equal to 7. So there are 7 electrons in the outermost shell of chlorine and 1 electron in the outermost shell of sodium. Now what happens when sodium combines with chlorine? We can show the electron transfer. There is a transfer of electron. Here, there is transfer of electron from the outermost shell of sodium to the outermost shell of chlorine. There is transfer of electron from the outermost shell of sodium to the outermost shell of chlorine. So what happens? Let us see. Let us show the structure of sodium like this and show the outermost electronic configuration. That is one electron in the outermost shell. And the actual configuration is 281. That is the configuration of electronic configuration of sodium. And there is only one electron in the outermost level. The valence shell, there is only one electron. Now plus, so chlorine has 7 electrons, 3s2, 3p5, this one, 3s2, 3p5. There are 7 electrons in the outermost level. And you show the outermost electrons only. Say 2 plus 2 plus 2, so 6, and there is 1 electron more. That is, there are 7 electrons in the valence shell. And the configuration of chlorine atom will be, actual configuration is 287, and that is the actual configuration of a chlorine atom. And during the formation of sodium chloride, as I told you, there is transfer of the outermost electron of sodium to the outermost shell of chlorine atom. So what happens? Sodium atom now loses 1 electron. When 1 electron is lost, it becomes a Na plus ion. By the loss of electron, positive ions or cations will be formed. Since 1 electron is removed, 1 electron is lost, there is unipositive ion, plus 1 ion. So sodium now becomes Na positive ion, Na plus ion. And in the Na plus ion, sodium ion, say the outermost electron is removed. So the configuration will be 2,8 only. 2,8. There are 10 electrons, only 10 electrons in Na plus ion. And what about the chlorine atom? Chlorine atom gets one more extra electron, and therefore the configuration of a chlorine now becomes, say like this. There is an addition of one more electron, and so it gains one electron, and therefore it becomes a negative ion. Negative ion, Cl minus ion. It is called the chloride ion. It is no more chlorine atom. It is chloride ion, Cl negative ion. So the configuration of Cl negative ion will be 288. 288. One more electron is added to the outermost level of chlorine, so that it becomes 288, and it becomes chloride ion with a unit of negative charge, and there is formation of Na plus and Cl minus ions, and there is attraction between these two ions, and that attractive force is called the ionic bond or electrovalent bond. And during the transfer of electrons, what happens? Na becomes Na plus ion. Na plus ion. In Na plus ion, there is 2,8 configuration. 2,8 means 10 electrons, and it is the configuration of the nearest noble gas, that is neon. Neon, atomic number 10. Neon, atomic number 10. And the configuration is 2,8. 2,8. 1s2, 2s2, 2p6, 2,8. That's the configuration of neon. There are 8 electrons in the outermost shell. Octet of electrons in the outermost shell of sodium atom. Now, what about chlorine? Chlorine has become now chloride ion, Cl minus ion. And there is 288 configuration, chloride. In 288 configuration, the number of electrons will be 18. 2 plus 8 plus 8. 18 electrons. And therefore, the configuration is similar to the nearest noble gas, that is argon. Argon, 288, atomic number 18. Atomic number 18, 18 electrons, and the configuration of argon is 288. Here also there will be 8 electrons in the outermost level of a chloride ion, octet of electrons in the outermost level of chloride ions. So during this process, atoms now become ions, and in the ions, in the outermost level, there will be 8 electrons or an octet of electrons, and the electronic configurations of the new species. That means the cation, positive ion, and anion, negative ion, will be similar to the configuration of the nearest noble gas. For example, here, sodium 2,8, Na plus 2,8, similar to the configuration of the nearest noble gas, neon, atomic number 10 to 8, and chloride 288, the configuration similar to the configuration of the nearest noble gas, argon, atomic number 18, and both are getting the stable configurations of the nearest noble gases. And this type of bond, what is the bond here? The bond is nothing but the attractive force between the positive and negative ions. The force of attraction between the cation and anion, and that is the ionic bond or electrovalent bond. Okay, and this type of bond formation, that is called the ionic bond or the electrovalent bond. Okay, we have seen that the nearest noble gas configuration or the stable noble gas configuration can be attained by the sharing of electron pairs, and such bonds are called covalent bonds. Covalent. So covalent bond. So what is a covalent bond? Covalent bond is the bond formed by sharing of electron pairs, sharing of electron pairs, sharing of electron pairs between atoms. Such bonds are called covalent bonds, and such compounds are called covalent compounds. So covalent bond is formed by the sharing of electron pairs between the combining atoms, and such molecules or such compounds are called covalent molecules or covalent compounds. So these are formed by the sharing. There is no complete transfer of electron from one atom to the other. Instead of that, the electrons are shared in pairs between the combining atoms. If only one pair of electrons, only one pair of electrons is shared. One pair of electrons is shared, then it is called a single bond. If only one pair of electrons is shared, it is called a single bond. And covalent bonds are shown by, see, dashes like this. So there is a single dash showing a covalent bond. And in the single dash, that means the covalent bond, there is a pair of electrons. The pair of electrons is shown by a dash like this. And it represents, the dash represents a covalent bond as well as a pair of electrons. If two pairs of electrons are shared between atoms, then it is called a double bond. There is a double bond between the atoms, and a double bond is shown by two dashes like this. Between the atoms, two dashes. In each dash, there will be a pair of electrons. So two dashes means two pairs of electrons. If three pairs of electrons are shared between the atoms, then it is called a triple bond. Say a triple bond. So triple bond consists of sharing of three pairs of electrons, and it is shown by, say, three dashes like this. Three dashes, say a triple bond. Let me come back. A covalent bond is formed by the sharing of electron pairs between the combining atoms. And such molecules are called covalent molecules, or such compounds are called covalent compounds. If only one pair of electrons is shared between atoms, it is a single bond. If two pairs of electrons are shared, then it is a double bond. If three pairs of electrons are shared between atoms, then it is a triple bond. All these things we have seen already. Okay, let us take some examples for this. Let us take the formation of H2 molecule. The formation of H2 molecule. Formation of H2 molecule. We know the atomic number of hydrogen H, that is equal to 1. And so the electronic configuration of hydrogen, as you know, it is 1s1. 1s1. That is the electronic configuration of a hydrogen atom. There is only one electron. The nearest inert gas is helium. The nearest noble gas is helium. The noble gas nearest to hydrogen is helium. And helium has 2 electrons. You know, helium atomic number is equal to 2, and the configuration is equal to 1s2. 1s2, that is the electronic configuration of helium. And here hydrogen hydrogen tends to attain stability of the nearest noble gas, namely helium, with 2 electrons. So hydrogen has to complete only doublets or a duplet of electrons. See, the others have to complete octet of electrons. For hydrogen, only the doublet or a duplet of electrons, just like helium, atomic number 2, 1s2. So what happens here during the formation of the Cl2 molecule, sorry, H2 molecule, say here is the hydrogen atom, nucleus of the hydrogen atom, and there is the outermost shell, and in the outermost shell there is 1 electron. There is only 1 electron. Now the second atom, the second hydrogen atom, see here, second hydrogen atom, and it is also having 1 electron in the outermost shell. There is only 1 shell. Now there is sharing of electrons between the 2 hydrogen atoms. So what happens now? Say in the valence shell of a hydrogen atom, you take this hydrogen atom number 1, hydrogen atom number 1. In the atmosphere of this hydrogen atom number 1, there are 2 electrons. Within the circle, the yellow circle, there are 2 electrons, and the 2 electrons, electron duplet, and it is similar to the helium configuration 1s2. You take the second hydrogen atom 2, and consider the atmosphere of the second hydrogen atom, or the shell of the second hydrogen atom. See here. So in the atmosphere of the valence shell of the second hydrogen atom also, there will be 2 electrons. So at the same time, both the electrons enjoy 2 electrons, just like the nearest noble gas helium, and so both the hydrogen atoms can complete the electron duplet or electron doublet, and this is the electron dot structure of a hydrogen molecule. So this way of representing the electrons using dots, that is called the electron dot structure. So this is the electron dot structure of a H2 molecule, and this can be shown in another way also. Instead of say the electron pairs shown here, you can show the electron pair like this. Say a pair of electron, second hydrogen. You can show the covalent bond like this also. A pair of electrons between the 2 hydrogen atoms. Or you can show this structure as H-H. It is not dash, it is a single bond. So hydrogen, single bond hydrogen, hydrogen, single bond hydrogen. So there is single bond between the 2 hydrogen atoms, and if the single bond is formed, both the hydrogen atoms can attain the stable electronic configuration of the nearest noble gas helium with 2 electrons, or a doublet of electrons, or a duplet of electrons, and so both the atoms can gain stability, by sharing of electron pairs. There is a single bond in H2 molecule. Let us take another example. You take, for example, chlorine molecule, second one, chlorine molecule, the formation of a chlorine molecule. You take the atomic number of chlorine. Chlorine atomic number is equal to 17. Atomic number is equal to 17. And what will be the electronic configuration? It is 1s2, then 2s2, 2p6, then 3s2, 3p5, 3s2, 3p5. That is the configuration of a chlorine atom. Okay. So during the formation of a Cl2 molecule, what happens? During the formation of Cl2 molecule, we can show the outermost electrons of chlorine, electron dot structure. There is chlorine atom, and there are, see here, 7 electrons. 7 electrons in the outermost level. Suppose we have the outermost shell like this. There are 7 electrons. 2, say plus 2, plus 2. So total 6 electrons. And one more. Say there is a 7 electron. There will be 7 electrons. Now you come to the second chlorine atom. Second chlorine atom, nucleus of second chlorine Cl. And there is electron pairing. So here we have 2 electrons. 2 electrons here. 2 electrons here. And one more electron here. 7 electrons. See? This is the way Cl2 molecule is formed. Now what happens when there is a sharing of electron pair? See here, a pair of electrons is shared between the chlorine atoms. So what happens to the outermost shell of chlorine atom? In the outermost shell of both the chlorine atoms, one extra electron is coming. In the outermost shell of both the chlorine atoms, an extra electron is coming. And therefore, instead of 3s2 3p5, the configuration becomes 3s2 3p6. The configuration now becomes 3s2 3p6. Say formerly it was 3s2 3p5. There are only 7 electrons in the outermost shell of chlorine atom. When electron pair is shared, a new electron, an extra electron is coming into the outermost shell, the valence shell of chlorine, so that the chlorine atom is getting one extra electron from the covalent bond. And so the configuration now becomes 3s2 3p6. Both the chlorine atoms attain the configuration 3s2 3p6. And the 3s2 3p6, this is the configuration of the nearest noble gas, that is argon. See, the complete configuration will be 1s2, 2s2 2p6, then 3s2 3p6, 3s2 3p6. And so this is the configuration of the nearest noble gas, and that is argon. Argon, atomic number 18. Atomic number 18. See here, 6 plus 2 plus 6 plus 2 plus 2. Totally, the number of electrons will be 18. 18. Total number of electrons, 18. And it is similar to the electronic configuration of the nearest noble gas, namely argon. Argon with the atomic number, 18. And so the octet in the outermost shell, of both the chlorine atoms, the octet is completed, 8 electrons completed, so that the nearest noble gas configuration is attained by both the chlorine atoms. And this can be shown in another way also, that is chlorine, electron pair, second electron pair, third electron pair, then say electron pair, here also electron pair, and there will be sharing of one electron pair between the chlorine atoms. Say like this, the covalent bond shown this way also. Or you can represent the structure this way. Say chlorine, covalent bond, chlorine. Chlorine, covalent bond, chlorine, a single bond. And there will be 6 electrons that are not taking part in the bond formation. And these are the non-bonding electrons or the lone pairs of electrons. There will be 3 pairs of electrons which are free in both the chlorine atoms. So that is the structure, electron dot structure. So this way of representing the molecules, you say electron dots in the outermost shell. Only the outermost shell is shown during the formation of bond. Either ionic bond or covalent bond. In both the cases, only the outermost shells of the atoms are shown. The inner core, the inner electrons, the inner core is not shown during the formation of the compounds or molecules. Only the outer electrons, the valence electrons, are shown by means of a dots, that's called the electron dot representation of a molecule. Let us take another example. Say third one. It is a H2O molecule. What will be the structure of a H2O molecule? In H2O, the combining atoms are hydrogen and oxygen. Combining atoms are hydrogen and oxygen. Hydrogen atomic number is equal to 1 and the configuration is equal to 1s1. There is only one electron. One electron. To attain stability, hydrogen has to get one more electron. So that there will be 2 electrons or a doublet or a duplet of electrons similar to the nearest noble gas, helium. You come to oxygen, atomic number of oxygen is equal to 8 and the configuration will be 1s2, 2s2, 2p. How many electrons will be there? 2p. Come on. 2p4, 2s2, 2p4. So in the outermost level of oxygen, there are only 4 plus 2, 6 electrons. And to complete the octet, oxygen needs 2 more electrons. This has to get 2 more electrons to complete the octet. While hydrogen needs only 1 more electron to get the nearest noble gas configuration. That is a helium duplet, doublet. And what will be the electron dot structure? Here we have H2O. You take the single atom at the center. You take the single atom at the center. So here there is oxygen. You show the outermost level. In the outermost level, there are 6 electrons. Say 2 plus 2, 4. And here there is 1 electron. And here there is 1 electron. 6 electrons. Now, what about the hydrogen atoms? Let us take the case of the hydrogen atoms. Say hydrogen atom, there is only 1 electron. Say like this. Similarly, second hydrogen atom, there is only 1 electron. Now there is the formation of 2 single bonds in H2O molecule. So you think of the green circle. Within the green circle, now there are 2 electrons, electron doublet, so that hydrogen can complete its electron doublet or a duplet, just like helium. Now come to oxygen. You consider the red circle or the pink circle. Inside the pink circle, now there are 8 electrons in the outermost level. So what happens to hydrogen? Hydrogen gets the configuration of helium. This also gets the configuration of helium, 2 electrons. And what about oxygen? This structure, 1s2, 2s2, 2p4, now changes to 1s2, 2s2, 2p6. There will be 8 electrons in the outermost level. And this will be the structure of the nearest noble gas, that is neon. Atomic number 10, neon. And in the outermost level, there will be 8 electrons. See? And this can be shown in another way also. That is hydrogen, a pair of electrons between oxygen atoms, another pair of electrons between oxygen and hydrogen atoms, and here there will be non-bonding electron pairs. electron dot structure of a H2O molecule. Both are correct. Both are correct. This can be shown in another way also. Do you remember that? Say hydrogen, covalent bond oxygen, covalent bond hydrogen, covalent bond hydrogen. And there will be 2 pairs of electrons. 2 pairs of electrons on the oxygen atom remaining. They are not taking part in the chemical reaction or bond formation. Okay, so there are 2 covalent bonds in H2O molecule. In all these cases, we have seen only the single bonds. All these are examples for single bonds. Now we have to see some examples for the formation of the double bonds also that we can see in the next class. Okay, let me stop now.